Welcome back to my YouTube channel. This is Mr. Sam. In this video, we are going to be discussing product rule, which is another rule of differential calculus. This is the third video in a series of videos for differential calculus. So if you are watching this video and you are new to differential calculus, try and watch the first video where I explained the general rule, then the second video where we talk about chain rule before watching product rule, because we are going to apply chain rule also in product rule. Now, talking about chain rule, there's something I want to quickly show you before we start this video. For chain rule, remember, you watched the video, we talked about the y dx being the y, the u times the u, the x, where you have to first find the y dx and also first find the u dx. Now, I'll be showing you a very quick trick that you can use to solve chain rule very fast. Because if you want to apply it under product rule, you might need to start going through the whole long process again. So please take note of this. I'll be very quick. So if y is equal to ax plus b raised to power n, this is a typical format for chain rule. When you see something kind of power, then you know it's chain rule. Then we can do it like this. You can say the y dx is equal to, see this power multiplied the coefficient here, which is 1, to come to the front, and then we have n equal ax plus b raised to power n minus 1, subtract 1 from the power, then times the derivative of what you have here, right, as d dx of ax plus b. This simple relationship will give you anything. Now, you can refer back to what you know on chain rule and compare the answer with what I will only solve one question, then we get to product rule fast. So if we have y equals, say, 2x plus 4 raised to power 5, using this rule, the y dx will be equal to 5 to come here into bracket 2x plus 4, then we have 5 minus 1, which is 4, times differentiation of what's inside the bracket. So differentiate 2x plus 4. This will just give you 2. 5 times 2 is 10, so we have 10 into 2x plus 4 raised to power 4. The same thing you will get if you use this rule. I hope that is clear, because I'll be applying this in some cases where we need to apply under product rule. Now let's get into product rule proper. So for product rule, we can say if y equals uv, in this case u times v, we have an expression that will represent as u and another one as v. They are multiplying, as the name implies, product rule. Two functions multiply each other. So we can say where u and v are both functions of x, then what is the y dx? The y dx is u dv dx plus v du dx. It is a relationship. You can bring this one to the front and this one to the back. Either one doesn't matter. You can say v du dx plus u dv dx, or this plus this. So basically, look at it very well. U will multiply the differentiation of v, while v will multiply the differentiation of v. So to understand this better, let's take examples. Alright, so these are the examples that we'll be solving for this video. I want it to be brief so I can understand it quickly. We are going to solve these three examples, and I'll give you some questions to also practice. Now, mind you, the difficulty level of each question you see under this might vary, but it will depend on your knowledge of indices and the first general rule of differential calculus. So if you don't know that yet, check the YouTube channel, especially for indices, and then the first one for differential calculus. Let's get into it. Solution number 1. We have y equals x plus 4 times 2x squared minus 3x plus 1. So the two functions are multiplying. So the first one will be u, and the second one will be v. So I'm going to do that by saying let u be equal to x plus 4. So let u be this first function. Then we'll now differentiate it. That will be the u dx. U dx will be equal to, we differentiate x to give you 1, differentiate 4 to give you 0. So the u dx here is just 1. So let v be the second one, equal 2x squared minus 3x plus 1. So if v is this, next thing to find dv dx, we want to differentiate. Differentiating 2x squared will give us 4x. Minus, if we differentiate 3x, we get 3. This one is 0. So now we have u, we have du dx, we have v, and we have dv dx. Those are all the elements of the formula behind dy dx under production. So dy dx is equal to u dv dx plus v du dx. Now we start to substitute. What is u? U is x plus 4. It will multiply dv dx. dv dx is 4x minus 3 plus v. V is 2x squared minus 3x plus 1. Then times du dx. du dx is 1. So now we have substituted them individually. It's time to simplify. So you can simplify this by expanding the brackets. X times 4x, 4x squared, x times minus 3, minus 3x, 4 times 4x, that plus 16x, plus times minus is minus 4 times 3 is 12. So if one multiplies all this, it will be the same thing. Since it's plus that is here, it's not really affect. But if it's minus that is here, we multiply everything by minus. So this is plus 2x squared minus 3x plus 1. Now we have like terms. We say 4x squared plus 2x squared, that is 6x squared, minus 3x plus 16 is plus 13x. Then minus 3x, that will be plus 10x. So we have minus 12 plus 1, minus 11. That is our final answer for differentiating this answer. How do I explain? Let's go to number 2. Number 2, we have y equals x minus 2. Then here we have 2x plus 4 raised to the power 5. So this, to differentiate this, we require chain rule. So this is the case where we apply chain rule under production. So let's start. So let u equal to x minus 2. Then we'll find du dx. Differentiate this to give you 1. So this one is represented 1. Now let v be equal to 2x plus 4 raised to the power 5. Now to find dv dx, instead of going through the whole process of chaining, just like I've said at the beginning of this video, we simply just find the fraction. The coefficient, the power here will become the coefficient here. So we have 5 into 2x plus 4 raised to the power 5 minus 1, 4 times the derivative of this. That is here. If we differentiate 2x plus 4, we get 2. So 5 times 2 is 10. So we have 10 into 2x plus 4 raised to the power 4. That is dv here. Now we are going to find dy dx. To substitute our, bring back our formula, we have u dv dx plus v du dx. So substituting now, u is x minus 2. dv dx is this. So that is times 10 into 2x plus 4 raised to the power 4. Plus v is this. 2x plus 4 raised to the power 5 times du dx. du dx is just 1. So now I want to simplify. Since this I'm multiplying, I can bring 10 to the front and say 10 into x minus 2 into 2x plus 4 raised to the power 4 plus 1 times this is 2x plus 4 raised to the power 5. We can continue. We can simplify this. In fact, we have like terms. This function is a like term in these two terms here. This one is carrying power 4, this one is taking power 5. We'll take one with the smallest power and bring it down. So we have 2x plus 4 raised to the power 4 into. Now, this is this. This will cancel out, and this is what we'll have left. We have 10 into x minus 2 plus this in this. 4 will cancel out of the 5 that I said. So we left only one of this. That is 2x plus 4. So if we simplify further, we have 2x plus 4 raised to the power 4 here into 10 times x, that is 10x minus 20 plus 2x plus 4. So we have 2x plus 4 raised to the power 4, 10x plus 2x here, that is 12x minus 20 plus 4 minus 16. This is going to be our final answer. You cannot simplify further, except you want to start opening brackets. And opening brackets is not simplification, rather factorizing is simplification. So this is the final answer to this question. I hope it's clear. If it looks like it's a lot, go back again and check it. Especially the calculation that was done here. If it's new to you, you have learned something new already. It is what we do to simplify finish. Now let's go to number 3. For number 3 now, we have y equals root x into x squared minus 2. So this on its own is a function of x. It is multiplying this. So I'm going to take them separately, and this will be u, this will be v. So we say let u be equal to root x, and this can be written as x raised to the power r. So what will be du dx? Du dx. Differentiate this. 1 is the coefficient times half. That's 1 over 2. Then x raised to the power half minus 1 minus half. So this is going to be 1 over 2 times 1 over x raised to the power half. And x raised to the power half is the same thing as the square root of x. So our answer here is 1 over 2 root x. So that is du dx. 1 over 2 root x. Now, the next one will say let b be equal to x squared minus 2. So we'll now find dv dx. Differentiate this and to give you 2x. This one is gone. So now we have u, we have du dx, we have v, we have dv dx. What's next? The formula. The y dx is equal to u dv dx plus v du dx. U is root x. dv dx is 2x. V is x squared minus 2. Du dx is 1 over 2 root x. So we multiply these two, like we have 2x root x plus this times 1, x squared minus 2, same thing, all over 2 root x. You can still simplify further by finding LCM and all, but I can leave my answer like this. That's one beautiful thing about calculus when it's product and chain. You can leave the answer here. If I say I should continue further, I can say okay, the LCM is 2 root x. This in this is 2 root x. 2 root x times this 2 times 2 is 4. So we have 4x. So the x times so that is also x. Plus this one is going to be this is this 1 times this x squared minus 2. So 4x times x is 4x squared plus x squared minus 2 all over 2 root x. If we add this, that is 5x squared minus 2 all over 2 root x. So this is a more simplified form and it's a more preferred answer. So if you are feeling confused, you can stop here. You might not get the full mark of an exam, but if you can finish it, this is your final answer. Alright, so these are the exercises that you have for this video. Try and solve them. Number 4 might be a little challenging, but you should be able to get it. Just follow through step by step, follow the steps. Make use of the knowledge of indices, and you get the answers to the questions. As usual, if you are new to my channel, subscribe so I can get notified when I post new content like this. You can share these videos with your friends so that they all benefit from the free knowledge that I'm sharing on my YouTube channel here. Thank you very much for watching. I'll see you in the next video.